we talk about data. Put that on your piece of paper. What is data? It seems like we've talked about this before, but hey. Data is nothing more than information. It pretty much makes the world go round. Listen to this small little tale and fact here, children. How many of you, raise your hand if either of your parents works in some sort of a computer industry? How many people work in computer industries, work with computers in some way, shape, or form? Okay, put your hands down. If you would have 80 years ago had asked that same question of fifth graders, first of all, do you know what? Most of their parents probably did what? Probably either farmers or they worked at a factory, maybe making cars or making whatever stuff, manufacturing sort of things. What?
I said gas.
Making gas, having gas?
Yeah, like converting gas,
refineries or whatever. Okay, that was like the manufacturing age. You people are growing up in an age that is a data age, which means so many jobs out there now deal with just information. Like the whole web. Back when I was a kid, we didn't have that. You guys, if you want to know something, you just go to your computer, you type in whatever keyword it is, and it pops up there. Me, if I want to know something, David, where did I go?
Dictionary.
Well, dictionary only tells you definitions of words. What if I wanted to know about Abraham Lincoln? What did I do? Library, you could go there, or we had things that were called encyclopedias, which were like a giant 15, 20 books that had, you would just look it up and read that sort of stuff. Okay. Today you have data and you have information, but the problem is data, and you could look at data as maybe just being facts. Facts. But data, okay, when it's in its raw form, like we call it raw data, does not really mean a whole lot. Now, I'm going to ask you a question. We're just going to jot this down to the side and then we'll talk about this. I just want to know how many kids are in your family. In other words, if you have to, I will ask you individually. You don't have to raise your hand. So I'll start with Allie. What do you got?
3.
And you can write this down. So there's a 3. Ben?
4.
Ben has 4. Amelia?
3.
3. That would be you and your brother and sister. David?
2.
2. You don't count your animals. Katerina?
1.
Just 1. Boom. Ella?
3.
3. So I missed that one. James?
1.
Just 1. Boom, boom. Aaron?
3.
3. Boom.
3.
3. Boom. Lex?
4.
4. Jameson?
3.
3. Ava?
3.
3. London?
2.
2. Grayson?
2.
2. Caitlin?
2.
2. Eliza?
2.
2. Dress? 2. Jax?
1.
We don't need to argue about it. It is what it is. That's what people say. That's what they are. There. Josh?
2.
2. Boom. So?
3.
3. And Sam?
3.
3. Okay. This right here, ladies and gentlemen, is what we call raw data because it is not organized. Okay? One of the ways we're going to organize it here is by using a frequency table. Okay? What does the word frequency mean? Anybody? If I asked you how frequently you have gym every day, or how frequently do you eat apples? Grayson, frequency means?
Like how much time, how much you do it.
Yeah, how many times? So here is how our frequency table works, and you can jot this down just like I have it on mine here. First of all, our label is this. We'll just call this siblings or families. It's just called siblings, even though it's not really a sibling, it's used. Okay, and we're going to organize this data. Okay, what are our choices here? Well, there's people that have just 1 in their family, people who have 2 in their family, people who have 3 in their family, people that have 4. Nobody here has 5, so we don't have to worry about that.
Ben does. Yeah, I didn't count myself.
Oh, so we do have a 5. Wait, you're this one right here, right, Ben?
Yep.
So we can change that. That's why I said counting yourself. Otherwise, we have zeros, and that just kind of messes me up. a little bit here. Okay. Tallies we've already talked about. Tallies, we use tally marks because it's an easy way to keep track of how many. So we're just going to do it one by one. We have a 3, a 5, a 3, a 2, a 1, a 3, a 2, a 1, a 3, a 1, 3, 3, a 4, 3, 3, a lot of 2s in a row, 1, 2, 3 there, and then 2 more and a 1, and then we have a 2 and 2 3s. Okay, now it's starting to get a little bit more organized, and you can kind of tell some patterns there. The frequency is really the same thing as the tallies, except we use numbers, because we don't want to have people have to count up little tally marks. So how often did the number 1 show up? 3 times. How often did number 2? 6 times. The number 3 looks like it ends up being 9 times, just once for a 4 and once for a 5. Now that kind of organized the data a little bit, and you can maybe make some thoughts on that. What would you think based on the information that's given there? You would say, well, most people have how many people in their family? 3. Which if you probably go and Google, what's the average amount of kids per family? It's probably 2.9 or 2.8 or 2.7 or whatever it is. You can also say we don't have a lot of people that have 5 in their family, all right, or 4. My father. Oh, yeah. We should have put Caleb. Let's put Caleb down just for fun. He has 6.
Or 7.
Let's just go with 6. Just because it fills out our table. My father was the youngest person born of 13.
What?
13 children. And that wasn't necessarily uncommon. Because back in the early days, back in the early 1900s, the more kids you had, the more people you had to help out on the farm. Because you had lots of acres. And you didn't have big tractors that could plow thousands of acres all in one day. People had to work and get up and milk the cows and all that sort of stuff. So having big families was to your benefit so that you could have a lot of workers. So here is our frequency table, and you can see how it organizes the data. Now I am going to take a picture of that, because then what we're going to do is we're actually going to take our frequency table and we're going to graph it for the next thing here, if I can find the thing. So I'm going to take my information here from my frequency table, make a new screen, pop it up here, make it a little smaller so it actually fits on my screen. Let's see if we got something here. And you can do the same thing, and then I'm going to get a picture of this. We are going to take that and we are going to, wait. Maybe I need to give you, I think I need to give you the other sheet. Hold on. With that, we are going to make a bar graph, or what we call a histogram. A histogram. I hope this is it. Yeah, this will be it. We're going to look at the bottom one of this. What lesson number is that? 32. Okay, find number 32. How about 32? 32. So we've got this. Look at the size of that. Does it say what it is here? Get this down over there. So we're going to take this information that we have and organize it into an even more friendly form so that you can just look at a graph and know exactly what we're talking about. So here we go. Paste. Paste. Scoop this off to the side. Maybe make it a little smaller so I can look at it. Okay, so first thing we have to do is label our graph, which it is what? Number of kids in the family. That's the title of our graph. That's what we're graphing. And when you make a bar graph, well, actually, we're going to call this a histogram. I'm going to write it down here. This is a histogram. A histograph, not a gram. And it's different than a bar graph because it doesn't have any spaces between the bars. No spaces. Now, when you do this, really what you're thinking about is doing this. To make it work on the bar graph, we're actually going to turn our little table on end. The bottom down here is going to be the number of siblings, or number in family. And this line going up is how many. Or we actually call this the frequency. This part is labeled the frequency, which means this is one person in the family, 2 people, 3 people, 4 people, 5 people, 6 people, 7 people, everything we got up there. So now, we need to do some little bit of splitting here. Okay, how many different numbers do I need down here? 1, 2, 3, 4, 5, 6. So I'm going to split my graph into 6 different lines. So here's cut in half, and each one of those split in thirds. So you got it as best you can. See if you can do this. This bar right here stands for people that just have 1 person in their family, 2 people in their family, 3, 4, 5, 6. I'll give you a chance to catch up there because I went pretty fast there. And if you're like David, you like to do nice straight lines, let them go. Number of kids in the family. That's what our graph is. That's what our data is about today.
Oh.
Because my board is not kind of chunky. Yeah, every time it hits a bump, it stops. Maybe that's the best I'm going to get. Let me try this. There we go. So here is how this looks. What was the frequency of people that had 1 person in their family? There was only 1 person. So you just color this up to the number 1 because there was only 1. Oh wait, was there more than? Wait, I'm not looking at my graph. There were 3.
No, just 3.
I don't have it on my, well, I'm gonna have to look.
Elijah, 3, 4.
All right, there were 3. So we have to color all the way up to the number 3.
Elijah didn't.
Elijah was not accurate with his calculating.
No.
It doesn't. We're just doing it. So you color in this all the way up to 3.
He said 2. He said 2.
We'll just be good with that.
It's fine.
How many people had 2 people in their family? 6 according to my graph.
7.
There's 6 on my thing, so I'm going with what I got. So here you'd have to color all the way up to 6. Of course, color is good. Now notice it's like a bar graph except there's no gap between the bars. How many folks had 3 in their family?
9.
Oh wait, I guess I don't. I'm gonna have to get off the graph. I guess we did go up to 9. So we gotta go all the way up to the line up there in kids. Actually, it works out pretty well on our graph. It's not too bad. How many people had 4?
1.
Just 1. Oh, we didn't have any 6s, did we? Wait, where did my 6 go? Oh, it's covered up by this. 5 was 1, and 6 was 1. 4 was 1. You got that?
Yeah.
So there again, that is data that is organized, and looking at that, you know, you can just really quickly look at it and tell how many people had just 4 in their family, or 5, or 6, or even 2 and 3. So that's, you always want to organize your data. This was kind of a whatever. Now, with that being said, I need you to take out another blank piece of paper. Lucky for you, this may end up taking the rest of the time.
Yay.
Put this under the letter M. Under the letter M. Oh, we got 2 more things. Now let's go with the letter L first. L. For line plot. We might run out of time. Okay, a second way to organize data is called a line plot, and that's a pretty simple thing once you see it. Okay, what you do is you make a number line, and you put an X for every data point. Or datum, I don't know.
Wait a second.
Okay, it's going to look a little bit like our frequency table, but not quite. So it looks like this. The first thing you have to know is on my number line, what are the numbers? If we're graphing this here, my numbers went from 1 all the way to 6, I think we put in there. Am I missing one on my numbers? So you would make a number line, 0, 1, 2, 3, 4, 5, 6. And then for every piece of data, you put an X above where that number is. So here, a 3, you put an X above the 3. A 5, an X above the 5. A 3, a second X above the 3, because that's our second 3. A 2, a 1, a third 3, a second 1, 2 more 3s, a 4, 2 more 3s, 5 2s in a row, 1, 2, 3, 4, 5, a 1, a 2, and 2 3s. This, boys and girls and children of all ages, is your line plot. So if they ask you to make a line plot, that's what it would look like. And again, it's just organized data that gives you a quick idea of what the numbers are you have. Usually with line plots, they talk about what are called clusters. And just like it sounds, if you're looking for a cluster, you know, this is a cluster. It's a big, when you just look at it quickly and you see a big grouping, that is your cluster. If there would have been a number out here like my dad, and it would have been way out here at number 13, because there were 13 in his family. If there's a number that's way out of the ordinary, that number is called an outlier. An outlier, because it lies outside of everything else. It's a little like, you know, you're the best math student in the world and you get nothing but 100s on every grade quiz, and then you get like a 50 on one. And 50 would be called an outlier because it's not typical, it's not normal, it's way off the thing. And usually you don't think about outliers because every now and then you just get something bizarre. Now, new piece of paper. And write down these words. Mode, median, mean, mode, median, mean, and range. Guess what we're going to do? Do we have enough time to do this? I think we have just enough time. Because you guys just want me to give you an assignment, call it a day and move on.
What?
You want to finish this and not have an assignment, or just have, oh,
Finish this.
and gentlemen, if you want the technical goofy name that math people call this, you can put it somewhere here. These things are known. You'll never, they are called measures of central tendency. And you don't have to know anything about it, just write it down there, because if you ever hear those words put together, this is what they're talking about. Measures of central tendency. And in order to do these, the first thing you have to do, step number 1, is you have to write your data from smallest to biggest. Which means this, and I'm going to have to write small. So I do this here. I have, what, 1, 1, how many? I have 3 1s. So I have to go 1, 1, 1. And then how many 2s did I have? You can probably tell me. Based on the other sheet, how many 2s did we have? 6?
7.
6, wasn't it?
It's 6. It's 6.
1, 2, 3, 4, 5, 6. I had 6 on mine. Maybe a 7 is the right answer. But then how many 3s do we have? 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And usually we don't have quite this many points. And then we have 1, 4, 1, 5, and 1, 6. 1, 4, 1, 5, and 1, 6. So that's the step that you need to do before you do any of this. Now watch how easy this is. The word mode just means the number that happens the most. What number appears the most in this whole group of numbers? Well, we know that because of our tables. The mode of that whole set of data is 3. Why? Because there were 9 of them. It happens the most. Okay. The next one is the one that gets a little confusing. Does anybody know what the word median means? On a road, you have a median. Grayson? Median is the middle. So if I have this group of numbers, I am looking for the number that falls right in the middle of all of them. And in order to do that, I need to know how many numbers I have. Is everybody here today?
Yeah.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Now that's a good thing. If you have an odd number of numbers, there is one that's exactly in the middle. It is number 11. Watch. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. The 11th number is right in the middle because there are 10 numbers on this side and there are 10 numbers on that side. So the very, very middle number is this number 3, and that is the middle, the median. Now you ask, but what if a number is not exactly in the middle? What if I would have had another 6 over here? Well, then these 2 numbers here are in the middle. If 2 numbers fall in the middle, you have to take their average, or add them together and divide by 2. If you add 2 3s together, you get 6. Divide by 2, you still get 3. So it doesn't matter in this case. But that's that. For you guys, this is good enough. The mean, guess what the word mean means? You've already done this. Mean is the same thing as average. How do we find the average? Add them all together, and in this case, I would have to divide by 21, which I'm not going to do just because it takes too much time. We don't have that much time. And then the last one is the range. The range is the difference, or what you get when you subtract the biggest, actually, you subtract the smallest from the biggest. Subtract smallest from big, which means my biggest number is 6, my smallest is 1. If I take 6 and subtract 1, my range is 5. There are 5 difference. There's a difference of 5 between the biggest and the smallest. That is the range. And ladies and gentlemen, you have now been more data than ever,